This topic is about solving a different type of logarithmic equation, specifically when you have logs on both sides and that's it, no extra numbers. Well, the idea to solve these types of equations is quite simple. Let me ask you a completely different but still relevant question. If I had 2 plus box and I claim that that equals 2 plus 5, can you tell me what that box is? I hope everyone said 5 because, well, logically, if these 2's are the same, then these guys must be the same as well, right? If apples equals apples, then oranges must equal oranges. And that's basically the concept behind these types of equations. If you have one log equaling the other log, well, as long as the bases are the same, their arguments must be the same. Let me write that down, what I just said in math terms. If log base b of box equals log base b of circle, then as long as the bases are the same, box equals circle. And before you ask, no, I'm not going to change up the bases for you. If you're really interested in how to solve these equations when the bases are different, talk to me after class and I'll totally show you a cool way to handle it. But for all the questions in this topic, all the bases will be the same. And again, this is a very logical idea. It's not that complicated. If the logs are the same, then the stuff inside the logs obviously have to be the same as well. So let's go ahead and go through a couple of examples. Suppose I ask you to solve log base 13 of 4x equaling log base 13 of 2 minus 4x, right? Well, okay. Well, on the left-hand side, if I have log base 13, on the right-hand side, I have log base 13, then this implies, so notice it's not an equal sign, it's an implication sign. So I'm not doing a math step. I'm not dividing both sides by log. That doesn't make sense. I'm not balancing an equation. I am making a logical implication by saying that then the argument for x must equal 2 minus 4x. So the logs don't, quote, disappear. They don't, quote, cancel out. We're just taking a valid math conclusion. But then, of course, this becomes a regular linear equation, which I hope everyone can solve. Add 4x to both sides, that's 8x equals 2, and then divide both sides by 8, giving you a quarter. Right. Do note, however, that logs are different in terms of what types of solutions they can have as compared to other functions like quadratic functions, linear functions. Note that logs have a restricted domains. The domain of log base b of x is 0 to infinity. In other words, we may only have positive numbers inside logs. So what, you say, what does this have to do with solving? This means when your equation has multiple logs, as is our previous example, we had 2 logs, one on the left, one on the right. If your equation has multiple logs, you must check your answers. Because we were doing a mathematical implication step rather than like balancing both sides, we may not be able to make this conclusion. We may not be able to make this previous step because our original problem may have been beyond the natural domain anyway. So it's not a huge thing that I'm asking you to do. Basically, what the extra layer I'm putting on you is when you're solving these log problems, just take a quick moment, plug your possible solution into the arguments and just make sure that it's not 0 or negative. If it does make any log 0 or negative, you have to throw them away. For example, let's do a quick one here. Log base 2 of negative x minus 8 equaling log base 2 of 5x plus 4. Okay, I'm solving this guy. Oh gee, the log base 2's are the same. So by logical conclusion, the arguments negative x minus 8 are the same, is equal to 5x plus 4. So let's go ahead and solve this. Let's add x to both sides. Let's subtract 4 from both sides. And let's go ahead and divide by divide by 6, giving us a negative 2. Right. Our math is fine. Our algebra is perfect. But according to the previous notes, we got to check our answers. So let's go ahead and plug in x equals negative 2. We have to check into both logs. So you have log base 2 of negative 2 minus 8 equals log base 2 of 5 times negative 2 plus 4. So that gives us a log base 2 of positive 2 minus 8, which is a negative 6, equals log base 2 of negative 10 plus 4 is negative 6. Now you're probably going, well, this is a good answer because they match. Well, however, notice there's a negative inside of a log. So technically this is not a good answer. This guy here doesn't exist. It's not defined. So although visually they do seem to match up, this is the same as that, technically speaking, they don't even exist in the first place. So this is actually bad, this guy right here. So what does this mean? That means our original answer, you gotta throw him away. He's not a real answer. Well, we don't have any other answers to check, so it's no solution. So that's basically how you solve log equals log problems. It's very simple. It's a logical deduction. If both logs are the same, then both arguments must be the same. The only way I can make this quote harder is if I make the arguments slightly more involved. So instead of linears, I could toss in some quadratics. Say, for example, solve log base 6 of 3x squared plus 12x. And I claim that that equals log base 6 of negative 32 plus 2x squares. Right? Well, okay, by logical conclusion, we can deduce that the arguments 3x squared plus 12x is equal to the other argument, negative 32 plus 2x squared. This is a quadratic equation because I have some x squares, so the technique to solve a quadratic is to bring everything onto one side. So let's move everything to the left. Let's subtract the 2x squares. And let's add the 32. So then let's go ahead and solve this quadratic. Solve it however you want. Factoring, completing the square, quadratic formula. I hope this guy is factorable. Yep, plus 8 plus 4. So get x equals negative 8 and x equals negative 4. Right? But wait, we had two logs in the original problem, this log and this log. And according to my warning, whenever your equation has multiple logs, you must check your answers. So let's check x equals negative 8. So we have log base 6 of 3 negative 8 squared plus 12 times negative 8 equaling log base 6 of negative 32 plus 2 times negative 8 squared. So that gives us log base 6 of, and this guy right here, just to save us some time, I'm just going to go ahead and go to the final answer. I'm just doing arithmetic. Use your calculator if you have difficulties with this. But that's what, 64 times 3. So 64 times 3, and I'm going to be subtracting, what's that, 96? So that gives us a 96. And that equals log base 6 of, that is 64 times 2. And I'm minusing a 32 gives us a 96 as well. So here, they both match and they're both positive. So this is a good answer. We keep him. Let's go ahead and check x equals -4. So we have log base 6 of 3 times -4 squared plus 12 times -4 equals log base 6 of -32 plus 2 times -4 squared. So we have log base 6 of, this is 16 times 48, minus the 48 is 0. See, I'm not going to even bother checking the other side because I already have a 0 here, and we know zeros or negatives are bad. So this is bad. You don't even have to bother checking the other guy. So x equals -4 is not a good answer. This problem only has one solution, -8. So that is the only way I can make this quote harder, is if I toss in some quadratics. So that is solving log equations, log equals log.